So I welcome you to today's coffee lecture on SoS, which is science of synthesis. And there's actually two reasons that we hold this coffee lecture today. One is that people need a regular reminder what this is and how to use it. You will see in a minute why that is. And the second is they have renewed a bit their web interface, so it's slightly different to use. And maybe if you've used it before, then it might be interesting to see what has changed. So first, well, SOS, what is it? It's not the international distress signal, uh, but it's actually a knowledge platform for organic synthesis. There's also information in there if you work with organometallic and coordination compounds, but that is in its essence the information that you find there. It used to be some shelves full of books. It's of course much nicer if you have a search interface than to go to an index book and find then out in which book you have to look for the information that you find. Initially, it used to be the Hoban Whale collection, and then since the 2000s, it's Science of Synthesis. Yeah, and this is why I need to talk about science of synthesis on a regular basis, because many users who try it out, they maybe know the much more well-known SciFinder or Reaxys, and then they try to use it in a similar fashion, and that doesn't work out, and then they think, oh yeah, this is not a good tool, so they stop using it. And so what I want to tell you today is what is the difference and how can you get better results. But maybe first, what can you find in there? So it's review type material. So the literature is aggregated, it's been selected, important examples are listed. We have reaction schemes, we have these important examples. We also have procedures that are representative. So if you think, oh yeah, I would like to do this reaction, what is a typical procedure? That's what you can find here. But then you also have discussions on the background, on the scope, maybe on issues that could occur. It's curated, so if you need a complete overview, then don't go there. But if you need to have an initial grasp of a new field, a new area of chemistry, then this is a very good starting point. You can search by structure, reaction, or text, and it's organized by functional group. And now here, that is the essential difference to when you go to SciFinder. In SciFinder, you typically start by, oh yeah, I draw the exact same thing that I want to find, so a specific molecule. And here you focus on a functional group, you focus on a heterocycle that maybe you want to create, you want to functionalize, and then you use that as a starting point. So draw as little as possible, and that will give you a good result. So that is all the secret here, but if you use it that way, then you will have good results. And I think now I want to go into the database. No, I think I've lost it, but we can go back. So it's sos.time.com. Time is the publisher. And so here we are at the start page. I will start with a text search. We are looking for N-acyloxy phthalamides. These are, of course, very popular for photochemical functionalizations. And then I have a result list here. It's 35 results for this. And then I have here one very promising entry about esters, what they are actually, because it's an acyloxy compound of the phthalimide. So let me click on that, and then we get redirected to this ebook view. And what I initially searched is now highlighted in yellow, what has been matched. So that's why there's all these yellow bits. But that can also sometimes help you to quickly see, oh yeah, where in this big text, so it could be much more than here, can I find what I'm looking for? And then we have references. And sometimes it's nice, sometimes not. So this is one of the changes in the new interface. So here, let me look at reference 200. And then I get redirected to another page. And then I have to go down and look at my 200. I think that could have been solved more elegantly. That maybe I get directly to what I want to see or have it as a pop-up. And then after this initial summary, it shows me, well, what can I do with these? So here, for example, photodecarboxylation with these esters. And then I have representative procedures where here my starting materials enters a catalytic cycle. And then a radical is formed that reacts, for example, here with an alkene. Yeah, I think this is basically the thing. Now, interesting is what kind of information do we find in here? Because, yeah, this is an ebook, a topical ebook. It's on photocatalysis in organic synthesis. And you see here we are in case studies for photocatalysis. But maybe if we get started, we also want some more theoretical background on photocatalysis and not only with these phthalimide, hydroxyphthalimide esters. And so we could, for example, go here to 2.1 and look at the basic ideas. And then we get a conceptual overview over how photocatalysis works. Also here with energy diagrams that explain, oh yeah, what are the conditions that need to be fulfilled that I can do a photochemical reaction. So that is very helpful here also. Ways that you could write this if you are then going to write a thesis, a paper, how could you depict what you have done in a chemical diagram and so on. So that was my first example, but of course we can also search for structures here. So let me quickly enter a structure and we're going to stick with some phthalimide. So I just copied in the smiles string. And then I search this and you will see, and that is maybe also something to take note of, that we get some different hits. So searching by text, of course, shows you all the text hits. And if you go to the structures, then you get the matches that are found in the graphics. And here I'm interested in some DNA functionalization. So I want to show an example from here. And you see, now I get actually redirected to the actual graphic where this comes, and I get this red circle as a little highlight. And then we see I have my phthalimide ester, hydroxyphthalimide ester as a starting material. Here we have a alkene that is attached to DNA with a linker, and I have my reactions. Then I have reaction conditions. And I think this is nice to get a feeling how well do these reactions work. I have different substrates listed here and I have the respective yields for these reactions. So that tells you, well, how good does this work? There may be also, maybe you are trying a new methodology and you want to find out, well, what is the literature precedent? If I want to say my method is better, how good do I need to make it? How much do I need to optimize? Or you could also look, maybe there are some entries in the table that are really bad yield-wise, and those could be interesting for you to say, well, we fill the gap in the literature, in the methodology, and that gives your method more value. And then if we go to the very end here, you see, because we have just looked at table 10, here is also a representative procedure. So this is the procedure that has been done to populate that table that we looked at above, and that can give you a quick overview. Oh yeah, what do I need? What kind of setup? What kind of reagents are used here? Is that something you want to work with or not? Yeah, that's the key information here. And now the final thing that I want to show you is sort of the functional group-based approach to look at things. So we've searched by text, we searched by structure, and you see here now I could search for some organometallics, which are ordered according to metal. I could look at certain heterocycles. So if you have never worked with benzothiazolene before, you may want to know what is the most acidic position to functionalize it, or where is the most electron-rich position if you want to do electrophilic aromatic substitution. these kinds of questions you can address here. Now I want to look at some thioacetyl or thioacyl chloride. So we're going to functional groups. And there is a entry here, thio, seleno, and telluro carboxylic acids and derivatives. And of course, acyl chlorides are derivatives here. And here I do find an entry on thioacyl halides. What I want to point out is that this material gets updated and that gets a separate entry. If we just go one down, then we see there is a second one, thioacyl halides update 2024. And so if we want all the information, we need to look at both of these. And here is another drawback. Oh, maybe it works here. Nice. So that is also, there's some browser specific differences. Before I was doing this in Firefox, then I could not open these individually, but I had to click and then go back and click on the second. Let's see if, no, it didn't work either here. Okay, it looked so promising. And now I get a pop-up. It looks slightly different to what we've seen before, but we can go to the ebook version and then we have the same visual or user interface. And I think the advantage here is that on the left, we have the index. And this is sort of divided into two. So first we have a general overview, but then we have the first part, how do we make this thing? And then the second one, application, what can I do from this thing? And those are often the questions you have to ask. Maybe you use it as a starting point for something, then you're more interested in the applications. If you want to synthesize it and compare your methodology, then of course you start with the synthesis part. And again, here in the general information, there is a lot of valuable information. For example, here it says, well, it's only isolable as an aliphatic thioacyl chloride if you don't have any hydrogens in the alpha position of the ester. So if you're planning out, oh yeah, I want to synthesize this substrate, and then you read this, then you know, oh yeah, you don't have to worry because it's not going to be stable. So you could try to make it and directly use it without isolating it, or then you forget about it and you do something else. Okay, I think with that, I'm at the end of what I wanted to show you. We're going to this. So a quick summary. In Science of Synthesis, you have curated and aggregated information, but it's a selection of the most important things you need to know. You can get a quick overview over functional groups, heterocycles, coordination compounds, how to make them, what to use them for. Often you have substrate tables, you have also conditions and preparations. Sometimes maybe it's not so intuitive to navigate. If you do it by this text index, then you really need to think, well, what are these things called that I'm trying to find, or how would you describe them? And it's very different from SciFinder and Reaxys. And if you are aware of that, then it can be really powerful. If you have questions on finding information and problems that you cannot solve yourself, do get in touch with either me or my colleague Emmanuel. We are here to help and also train you further if you cannot solve the problems that you have. There is a coffee lecture card for this that summarizes just the important points. And I want to highlight that tomorrow you can learn about the inorganic crystal structure database here with Yoshitsa Dolens.